Hi grade 10 students, I am Ma'am Judy Bungala. I will be your math teacher to discuss to you quarter 4 week 8, which is about mutually exclusive events and probability of union of events. Let's first recall what union of events mean. So union of events is a set of all outcomes that belong to A or B or either in A or B. It is denoted by A union B. Another illustration for union of events is the second figure. It is also denoted by A union B. But what's the difference between the two figures? In the first figure, this is called as mutually exclusive events, while in the second figure, it illustrates not mutually exclusive events. And other than that, what's the difference? For the mutually exclusive events, they do not intersect. That's why they are separate entities. While for not mutually exclusive events, they intersect. For the mutually exclusive events, they have no common element, but for the not mutually, they have common element or elements. Also, mutually exclusive events cannot happen at the same time, while not mutually exclusive events can happen simultaneously. An example of mutually exclusive events are sleeping and cooking. So you can't cook while sleeping, or you can't sleep while cooking because that's a dangerous thing. An example for not mutually exclusive events is singing and cooking. So you can do both simultaneously. Okay, so using the definition or characteristics of mutually exclusive events and not mutually exclusive events, identify if the following events are mutually exclusive, ME, or not mutually exclusive event, non-ME. So this is the situation. A ball contains 10 balls numbered 1 to 10. Identify if the following events are ME or NME. First, getting a 2 or an even number. Number 2, getting an even or odd number. Number 3, getting a composite or odd number. Okay, time's up. So for number 1, these events are not mutually exclusive events. Why? Because if we are to identify the outcome for getting a 2, we have 2. And getting an even number, the possible outcomes are 2, 4, 6, 8, and 10. So notice that they have a common element, which is 2. That makes them not mutually exclusive. That means they have an intersection. For number 2, getting an even or odd number. This one, they are mutually exclusive events. Why? Because the possible outcomes for even numbers are 2, 4, 6, 8, and 10. And for odd number, we have 1, 3, 5, 7, 9. So they don't have a common element or they don't intersect. That's why they are mutually exclusive. And for the third one, getting a composite or odd number. So remember what we mean by composite? So it has other factors aside from 1 and itself. And from numbers 1 to 10, the composite numbers are 4, 6, 8, 9, 10, and the odd numbers are 1, 3, 5, 7, 9. So do they have a common element? The answer is yes, which is 9. So therefore, they are not mutually exclusive events. Also, let us illustrate using the Venn diagram the events. The first event, getting a 2 or an even number. So let A be 2. Let B all the possible outcomes for even number. We have 2, 4, 6, 8, and 10. So, meaning to say we have 2 circles, and take note that they do intersect. So for A, let that be your set A, your first circle. And your B is this one. So as you can observe, A is inside B. That means A is a subset of B. And also take note, the numbers we have in B only, we have 4, 6, 8, and 10 because we already have 2 in A, which is also inside B. So, they are not mutually exclusive events. For number 2, getting an even or odd number. So, let A be the set of getting an even number. The possible outcomes, we have 2, 4, 6, 8, 10. And for B, possible outcomes for odd numbers, we have 1, 3, 5, 7, 9. So we cannot see any common element. Therefore, the two circles are disjoint. Okay, so they are mutually exclusive events. For number 3, getting a composite or odd number. So let A be the possible outcomes for composite numbers. We have 4, 6, 8, 9, 10. And for B odd number, we have 1, 3, 5, 7, 9. So they have a common element, which is 9. So that means the two circles or the two events intersect. So let this be A and let this be your set B. And what is common to them is 9. That's why we put the 9 in their intersection. So since they intersect, so they are not mutually exclusive events. Okay, so how about finding their probability? So for the mutually exclusive events, that's just very simple. To find the union, the probability of the union A and B, we have to add the probability of A and the probability of B. For not mutually exclusive events, we have also A union B, so we have to subtract their intersection. Why is that so that we have to subtract their intersection? It is because if we are not going to subtract it, the intersection will be counted twice and you will get a faulty answer. So take note of that. For not mutually exclusive events, we have to subtract their intersection. For the mutually exclusive events, since we do not have an intersection, technically it will just be 0. So we don't anymore add here or put here the minus intersection. So using the same events, let us identify or solve for their probability. So we have identified the events if they are ME or NME and then solve their probability. So for number 1, getting a 2 or an even number, we already identified it as not mutually exclusive events. So therefore, we will be using this formula. The probability of A plus probability of B minus their intersection. So recall how we identify the probability of an event. That is the number of outcomes divided by the total number of outcomes. So for the probability of A, let A be getting a 2. So the possible outcome is 2. And for event B, the possible outcomes for even number is are 2, 4, 6, 8, and 10. So for the probability of A, we only have one element over 10 since we have 10 numbers. So we have 1 over 10. And for the probability of B, we have 5 elements here over 10. And then minus their intersection, do we have an intersection? Do we have a common element? The answer is yes. And the common element, we only have one common element. That's why we have minus 1 over 10. And you perform the operation, we will be getting an answer of 5 over 10 or 1/2. Or you may also express 1/2 into decimal or percent form because probability can be expressed in terms of fraction, decimal, or in percent form. For number 2, getting an even or odd number, we already identified the event as mutually exclusive. So, therefore, they don't have an intersection. So simply, we're just going to, their intersection is 0. So simply, we're just going to add the probability of A and the probability of B. So for the probability of A, this one is your A. Possible outcomes for even numbers, possible outcomes for odd numbers. For the even numbers or probability of A, you have 5 elements all over 10. And then for B, also have 5 over 10. So we add them. So you will get 10 over 10 or 1 or 100%. So that means getting an even or odd number is a sure event. 100% it will happen. For the third event, getting a composite or odd number, we already identified it as not mutually exclusive event. So let A be your composite numbers, possible outcomes 4, 6, 8, 9, 10, and for B odd numbers, we have possible outcomes 1, 3, 5, 7, 9. So since they have an intersection, they are not mutually exclusive events, we're going to subtract their intersection. So probability of A is 5 over 10. Probability of B is also 5 over 10 minus their intersection. They only have one common element, which is 9. So that's why we have minus 1 over 10. And perform the operation, you will arrive at 9 over 10. Okay, or that is 0.9 or 90%. Meaning to say there is a 90% chance of getting a composite or odd number. That's quite high. So as a summary, mutually exclusive events are disjoint events, meaning to say they cannot happen at the same time. They don't have an intersection. Not mutually exclusive events are events which can happen at the same time. So they have an intersection. And to find the probability of union of events for not mutually exclusive, that is the probability of A union B equals the probability of A plus the probability of B minus the intersection of A and B. For mutually exclusive events, that is, you're just going to add the probability of A plus probability of B. So you don't anymore subtract the intersection because obviously their intersection is 0 since they are disjoint. I hope that this video lesson will help you in answering your Week 8 module, such as your practice exercises, evaluation, and your fourth summative test. Thank you so much and God bless.